Oh, IGCSE Physics. Hello, IGCSE Physics students. I am Tanya Chew. In this video, I am going to discuss Cambridge IGCSE Physics Paper 4 Theory Extended Paper. The paper that I'm going to discuss is May June 2025, Paper 41. Let us get started. Now, we are going to begin with the first question. Number 1A, circle the vector quantities. You have to understand, what does this vector quantities mean? Vector quantity means that the quantity contain not only magnitude means the value together with the unit, but also direction. Direction meaning to say that up, down, left, right, okay, north, east, south, west, these are all called direction. So there are two vector quantities in this list. They are acceleration and velocity. B, Fig 1.1 shows the speed time graph for a train traveling from station A to station B. First part, state the maximum speed of the train. Now, in order to get your maximum speed, you have to look at your y-axis, look at the horizontal line, yeah, match the value on your y-axis. So the value here is about 1, 2, 3, 4, 5, 6. It is 56. So the maximum speed is 56. Don't just leave 56 like that. State the unit, meter per second, because you have to check the unit from the y-axis. Meter per second is the unit of speed. The second part, describe the motion of the train between station A and station B. Now, this is the whole graph. This is the whole graph showing that the train, right, the speed of the train that is traveling from station A to station B starts from station A first. Right. Now, okay, I'm going to look at the graph, start from t equal to 0. So I'm going to describe one by one, step by step. So I'm going to say from t equal to 0 to t equal to, this is a straight line graph until this time. Okay, I need to draw that time. I need to get the time for this. So when the train reaches the maximum speed. So this is a time. Okay, done with that. I also need to get this time right here. Okay, now let me do it nicely, a bit closer. Okay, I need to get, because I have the value of the maximum speed, so I just need the time to describe. Now I keep my ruler first. Okay, the time over here is 80 seconds. This is 480 seconds. So I'm going to talk about this first. From time equal to 0 to time equal to 80 seconds. You could see that this graph is a straight line graph, right? So straight line graph, because the question asks us to talk about the motion. When the question asks you to talk about the motion, you can talk about the velocity, the speed, or even the acceleration of the train. So I can see that from the straight line graph, the speed increases linearly. So I want to bring in my acceleration, because I know that from the gradient of the speed time graph, I could get acceleration. When the graph is being given, you can find two information from the graph. One is the area under the graph. The other one is the gradient of the graph. In this case, the gradient of the graph represents acceleration. And so happened that the question asks you to describe the motion. Instead of describing the speed, which I can see from the graph, I would like to talk about the acceleration. So this is a straight line graph. Straight line graph will always give you constant gradient. Gradient of the graph, I'm going to write this down for you, is equal to acceleration. Since the gradient is constant, train is moving with constant acceleration. So I'm going to write that. Train is moving with constant acceleration. And then after that, what happened? From 80 seconds to 480 seconds, you look at the speed of the train, it is constant. This is horizontal line. So the train is moving at constant speed from t equal to 0, t equal to 80 seconds to t equals to 480 seconds. Train is moving train is moving at constant speed. And I'm done with that. And then from 480 to 501 to 530 seconds, you could see that the speed of the train decreases constantly until it reaches zero. So I would say that, I will talk about the acceleration. Since this is a negative acceleration, I would say that the train decelerates constantly, uniformly, from t equals to 480 second to t equals to 530 second, train decelerates uniformly. Whenever you are asked to describe something, describe the motion, try to use more of the word like constant, uniform, increasing, decreasing, something like that. Yeah, that is the answer. Now, this third part, calculate the distance between station A and B. Like what I told you, I say when a graph is being given, you can obtain two information from the graph. Since the gradient of the graph represents acceleration, right? Now the area under the graph represents the total distance traveled by the train. Like, okay, let me look at the mark allocated. It is 3 marks. When 3 marks is given, bear this in mind. You have to write down how do you calculate the distance or how do you obtain the distance from the graph. So I'm going to say that distance is equal to area under graph. And now look at the graph given again. This is a speed time graph. It is the area of trapezium. So I'm going to find the area of trapezium. But do you still remember the equation or the formula of trapezium? Half A plus B times the height. I'm going to put half first. A is actually this part. I'm going to highlight it for you. This is A. A. This is called A. So I'm going to write down the value of A first. How do you get A? So you need to get two values to get A. A is from 80 to 480. So I'm going to write down A is 480 minus 80. So you get 400 for A. For B, this is B, this is B. This is called B. All the way to the end of the graph from 0 to 530. So B is equal to 530. And the height of the graph, it is 56. So I'm going to put A plus B. Okay, 400 plus 530 times 56. And the value is 2.6 times 10 to the power of 4 meter. 2.6 times 10 to the power of 4 meter. So remember to include your unit. Now, the last part, on a different day, the train takes 650 seconds to travel between station A and station B. Suggest one change to the motion of the train that leads to this longer journey time. Motion, one change to the motion. What happened? What happened to the motion of the train that it take longer time? Since you look at this part of the question, right? Part 2, I described the acceleration. So I would like to bring in acceleration of the train as well. You see, A is equal to V minus U over T. Do you still recall the equation or the formula of acceleration? Longer time, meaning to say that lesser acceleration, or the train started with lower acceleration, or the train has lower deceleration. It is up to you. So I'm going to say that one change to the motion. So the train starts with lower acceleration from station A. From station A. Or you could also say that this train, yeah, has a lower deceleration to reach station B. That's it. Now, number 2A, a resultant force is applied to an object moving with a velocity v in a straight line. State two different changes to the motion that the resultant force may cause. Now, changes to the motion. So, changes to the motion. What happened? Motion, you can talk about the speed, you can talk about the acceleration. I would say that maybe it will cause the objects, okay, it will cause the speed of the object to change, right? Speed of object changes. This is one of the motion. And if I also want to say that it causes the acceleration or the velocity of the object to change, but acceleration and the velocity are related to vector quantity. So you might want to say, you cannot say the velocity of the object changes because it is in a way similar to the speed because magnitude of the velocity is equal to the speed. So I'm going to say that maybe the direction of the object to change that causes the acceleration to change, right? Direction of object changes. That. Now the second part, state one other way that forces more than one force may change a stationary object. You know, when an object is stationary, let's say a small plastic ball is on the ground, I apply a compressing force. I compress the ball. So what happened to the ball? The ball becomes smaller because I compress the ball. Or I just apply stretching force. I stretch the plastic ball. So what happened to the plastic ball? But not too much because I don't want the ball, I don't want to spoil the ball. So I stretch just a little bit. It will change the shape of the ball, right? So these forces may change the shape of the ball, okay? Change shape of the ball. Or you can say the change the dimension of the ball, change the size of the ball. Now, B, describe how a uniform, remember, when you see this word uniform, right? Let me explain a little bit. Uniform meter rule. You definitely know that you have seen meter rule before in your lab. When the question mentioned it is a uniform meter rule, bear this in mind. The center of gravity of the meter rule must act at 50 cm mark or at the center of the whole length of the meter rule. A uniform meter rule, a pivot, and a selection of masses can be used to demonstrate that there is no resultant moment on a uniform on an object in equilibrium. And you may include labeled diagram in your answer. Definitely, I would include the label diagram to help me to answer better. Now, I would say that this uniform meter rule may be balanced at 50 cm mark. So I'm going to put here 50 cm. And then this is my pivot. Don't just write it. You have to label. This is my meter rule. And then selection of masses. Okay, the masses that we have are all slotted masses. So what I'm going to do is that I'm going to place one on one side first and the other one on the other side. So I'm going to place maybe 20 gram here and then 10 gram. Maybe I'm going to shift that 10 gram so that the meter rule is balanced again. Now, I'm going to describe, yeah? Okay, now I start with my description. First one, meter rule is balanced at 50 cm mark. And a pivot is placed at 50 cm mark. Done. And then the second one, maybe a 20 gram mass is placed on the left side of meter rule. And then third, another or a 10 gram because I'm using different masses. So a 10 gram mass is shifted on the left, on the right. So sorry, this is right side of the meter rule. As you can see from my diagram, on the right side of a meter rule until ruler is balanced again. Done. And then, okay, how do I show the anti-clockwise moment is equal to clockwise moment? Now, I want you to see this very carefully. I want you to see that this 20 gram, there's the weight of the 20 gram. The weight of the 20 gram, right, produces, this is called anti-clockwise moment. Weight of the 10 gram produces clockwise moment. I am going to write that down. Now, anti-clockwise moment produced by 20 gram mass equal, still remember how we calculate the moment? Force multiplies by perpendicular distance from the pivot. Right, so force, that means weight of 20 gram, mass of 20 gram. Okay, or I just put 20 gram. I just replace the mass of the 20 gram. Okay, force is weight, right? So this mass, you bear in mind, to find your weight, your mass must be converted to kilogram first. So 20 divided by 1,000, 1, 2, 3, it is 0.2. Okay, 1, 2, 3. Okay, it is 0.02. Okay, this is 0.02. 0.02 kilogram, right? Multiplies by 9.8 meter per second and multiplies by perpendicular. Oh, I'll just put it in my diagram so it is easier. So I'll put it in my diagram. This is D1. This is D2. Easier. So when I draw a diagram, I have already labeled it on my diagram. So it's easier for me to just put it like that, like this. D1. So the clockwise moment produced by 10 gram mass is equal to 0.01 kilogram multiplied by 9.8 times D2. Is it D2? Yes, D2. So add one more as predicted conclusion. Okay, so if anti-clockwise moment is equal to clockwise moment, resultant moment must be zero. And the object is in equilibrium. Done. Number 3, Fig 3.1 shows a side view of a part of a concrete track at the skateboard part. A skateboarder is initially at rest at point A. The skateboarder then travels through point B and comes to rest at point C. Describe the transfer of energy as the skateboarder travels from A to C along the concrete track. Wow, this is 2 marks question. So I would say that skateboarder is initially at rest, U equal to 0. So the only energy that the skateboarder has at point A is the gravitational potential energy. So I'm going to write that, okay? At point A, skateboarder B or skateboarder has gravitational potential energy. And when the skateboarder move from A to B, right, then, okay, the energy is going to transfer, right, okay, when when skateboarder moves to, because the question did not mention that there is no energy loss. I would assume, I cannot assume that the energy conversion is between gravitational potential energy and the kinetic energy. Why? Because at the end of the time, you could see that the landing of the skateboarder, right, at C, which is lower than A. That means some of the energy could have lost to overcome heat or friction between the skateboard and the concrete track. So skateboarder moved to B. Okay, gravitational potential energy is converted to kinetic energy at B. And okay, as the skateboarder travels to C from B, some of its kinetic energy is dissipated in overcoming. So describe, okay, in this overcoming frictional force between, if you want to explain further, if you want to describe further, between track and skateboard. To overcome. So at C, skateboarder has lower gravitational, wow, I read too long, potential energy. Because some of the energy has already been lost. Friction means it causes heat. Right. B part one, I'm so sorry for the long answer. I just want to make sure that you understand. Right. B part one, B is at ground level and C is at 2.8 meter above ground level. Mass of the skateboarder is 65 kilogram. Calculate the work done on the skateboarder as she travels from B to C. Work done because there's a height given. Do you know that energy is work is ability, or energy is ability to do work, right? So that is why work is converted to her gravitational potential energy. Gravitational potential energy. Her gravitational potential energy is mgh. So the mass is 65 kilogram. G, remember, 9.8, and the height is 2.8. Now, your answer is 1.8 times 10 to the power of 3 joules. 1.8 times 10 to the power of 3 joules is the answer. Second part, the skateboarder falls off the skateboard at B. She hits the track and comes to rest after a few milliseconds. State the equation that defines the force F with which the skateboarder hits the track. State the meaning of any symbols you use. I am going to use this. F equals mv minus mu over t. That is the definition of force. Now, I will explain the symbol that I use because F I don't have to explain because the question has already explained for me. I'm going to put mv is her final momentum because she's moving. And then she hits the track and come to rest. So her final momentum must be equal to 0. And then mu is the initial momentum. And t is the time taken. Done. Now, number 4, Fig 4.1 shows a heater used to warm the air in a room. A part 1 state the main method of thermal energy transfer throughout the air in the room. So inside a closed room, how the thermal energy is being transferred, it is called convection. Explain how the heater warms all the air in the room. In other words, you have to explain how the convection has occurred, right? So I'm going to explain in detail as the air above, just above the heater absorb heat from heater, they gain kinetic energy. Remember, in energy. The energy that is related to temperature is kinetic energy. So what happened? Distance between them increases as they move because they have more energy, so they move faster, so the distance between them increases. After all, this is in the room, right? As they move. Now, okay, due to the distance between the air particles increases, volume increases. So when volume increases, do you still remember the equation of density? I'm going to write here, right? Density is being defined as mass over volume. So since the mass of the air particles, same number of same number of air particles inside the room, so the mass of the air particles will be the same. Now the volume increases, what will happen to the density of the air that close to the heater? The density would decrease. Huh? Density decreases. So when the density decreases, they are less dense. Less dense object will move upwards, so they will rise. So dense, less dense air particles rises to the top of the room. So what happens when the air particles, the less dense air particle rises, they will leave behind these vacancies. Right, so these vacancies, okay, will be immediately filled by the air particles that is not so hot because they have not enough kinetic energy to move further away from each other. So their volume, as compared to the heated air particles, their volume is lesser. So when their volume is lesser, their density is higher, right? So what happened? Okay, air particles which are colder or less hot, okay, have a smaller volume due to lesser kinetic energy. So they cannot move further apart from each other. So the denser air, because smaller volume is denser, the denser air particles move downwards. Okay, move downwards towards the heater. So the process circulation, this is called circulation. Hotter air rises, colder air move downwards. This is called circulation of the air particles, causes the room to be, okay, circulation of air particles causes the room to be warm. Done. B, the power of the heater is 2 kilowatt when it is connected to the mains supply with an EMF of 230 volt. First part, show that the current in the heater is approximately 8.7 ampere. So since the power, the voltage or the EMF is being given, I'm going to use P equal to IV. I is equal to power over EMF. Power is given as 2 kilo. 2 kilo means 2000 watt. You have to change to watt first, over 230 volt. So I is equal to 8.6957A. This is not my final answer. When the question asks you to show approximately equal to 8.7 ampere, you got to write more significant figures to show that you prove, okay? To show you have calculated the value. Then only approximately equals to 8.7 ampere. Now, the second part, the plug connecting to the heater to the mains supply is fitted with a fuse. Fuse ratings of 3 ampere, 5 ampere, 10 amperes, and 13 amperes are available. State which fuse is used. Explain your answer. Since the current is only 8.7, I'm going to choose the fuse rating a little bit higher than 8.7 ampere. I'm going to choose 10 ampere. Explanation is because fuse rating is the maximum current that is allowable to flow through the fuse. What is the function of the fuse? Fuse is to protect the electrical appliance, right? So if the current of the fuse rating must be a bit higher than the current required by the appliance, right? So my explanation is that if the fuse rating if the fuse rating is lesser than 8.7 ampere, maybe 5 ampere, right? What will happen? Heater will stop working because heater needs 8.7 ampere. Heater stops working because it is not enough current for the heater to work. But, okay, if the fuse rating is way higher, okay, way higher than 8.7 ampere, okay, maybe, okay, right, or 13 ampere, okay, then, okay, too much current flows through heater and might damage it. So that is one. You want the fuse rating to just be a little bit higher than the heater required, the current required by the heater. That's all. Number 5, a ray of light is incident on a soap film. Fig 5.1 shows a magnified image of a small part of the soap film. The ray of light is refracted as it enters the soap film. The refractive index of the soap film is 1.28. Define refractive index in the terms of the speed of light. There are many ways for us to define refractive index. In this case, you have to define it in terms of the speed of light. So I would say speed, okay, refractive index is equal to speed of light. In this case, it's in air divided by speed of light in medium. I'm done. B, show that the angle of refraction as the light enters the soap film is about 43 degrees. Now, okay, I need to draw my normal. Do you still remember how we determine our incident angle, refracted angle? Right. Okay, you have to be extra careful right here. Now, this is what we call, I'm going to use red color so that you can see, this is called incident angle. Why I call it as incident angle? Because look at the arrow of the ray. Arrow of the ray is coming from the air. This is incident angle from less dense to denser because so it's definitely denser. So it will be refracted just, okay, close to normal. See that? Keep my ruler. So this is the angle of refraction, R. So when the light ray travel from less dense medium to a denser medium, and refractive index is equal to sine I over sine R. Refractive index of the soap film is given, which is 1.28. Sine incident angle. Incident angle is this one. How do you get incident angle? You have to take 90 degrees minus 30 degrees. Don't make careless mistake. 60 degrees is the incidence angle. So sine 60 degrees divided by sine refracted angle. Sine refracted angle is equal to sine 60 divided by 1.28. R is equal to shift sine 60 divided by 1.28. Get an answer? right? Remember to convert your calculator to degree. We are not going to use a radian. Don't make this careless mistake. So R that I got was 42.577 degrees, and I rounded off to approximately equals to 43 degrees. Second part, on Fig 5.1, carefully draw the refracted ray in the soap film and label the angle of refraction. So I have already drawn my angle of refraction is equal to 43 degrees. And I'm done with that. Now, see, the ray of light is monochromatic red light with a wavelength of 680 nanometer in air. Define monochromatic. Monochromatic means the wave which has only one frequency. Done. And calculate the frequency of the light. So you remember the equation of the light wave, speed of light or speed of wave, V equals to F lambda. F is equal to V over lambda. V is the speed of light in air, which is 3 times 10 to the power of 8. It seems like lack of information, but you have to remember speed. Light travel with the speed of light in air as well as in vacuum. Now, the wavelength is 680, but nano is 10 to the power negative 9. So the frequency is 4.41 times 10 to the power of 14 hertz. Unit of the frequency, you have to beware, it is hertz. Done. Now, Fig 6.1 shows a person using magnetic window cleaner. The part of the outside of the window is attracted to the inside part of the glass window. Each part of the window cleaner contains 2 magnets. Fig 6.2 shows the magnetic field between the parts of the window cleaner. Now, A. Glass is not a magnetic material. State the difference between magnetic and non-magnetic material. Okay, I am going to state that magnetic material are attracted. They are only attracted, okay, attracted to magnet. Whereas non-magnetic materials are not being attracted to magnet. Done. B. Suggest a suitable material for the magnets in the window cleaner and explain your answer. I'm definitely going to suggest steel. Why? Because I want the magnetism in it to stay forever so that I don't have to change the window cleaner. So that it is always magnetized, or it stays magnetized all the time. I don't have to change to another window cleaner. How about that? See, label the poles of the magnets in Fig 6.2. Before you label, okay, the hint is already been given. So the hint stated that this person using magnetic window cleaner, the part outside of the window is attracted. Attraction, that means the 2 poles must be opposite. So north pole is here, south pole is here, or south pole inside, outside North Pole. Done. Now, state how the field lines in Fig 6.2 shows different strengths of the magnetic field between the magnet. That means closer magnetic field lines, stronger the strength of magnets. Wider, okay, magnetic field lines weaker the strength of magnets. Can you see that? So this is stronger. Stronger is close to the pole. Now, the next one, number 7. Fig 7.1 shows a sketch of current voltage graph for an electrical component. First part, name the electrical component and explain how you identify the component from the graph in Fig 7.1. The name of the component, it seems like component is not connecting, okay? There's no current flow when there's also no voltage, when the current and the voltage are both negative values, and there is no conduction occur until a certain voltage is being reached. You can see here, until a certain voltage is being reached, right? Then only conduction will occur, then only current will flow, right? So that component is called diode. Diode is made up of, there are two, okay, types of diode, silicon and germanium, right? So explanation, it is because current flow, okay, current flows in one direction only. So remember, the function of a diode, it will only allow the current to flow in one direction. And draw the circuit symbol for this component is this triangle with a block here to block the current from flowing. So the current can only flow from left to right. But the current, if the current wants to flow from right to left, so this block right here will block the current from flowing. B, Fig 7.2 shows an electrical circuit for two identical electric heaters, A and B, connected to mains supply 230 volt. As one is closed, I'm going to close it. As two is open, the reading on the ammeter is 3.9 ampere. Okay. Calculate the resistance of heater A. 2 marks given. So the resistance of the heater A is related to, okay, Ohm's law. We can use Ohm's law. I'm going to use the V equals to IR. Resistance of the heater A is equal to V over I. V is equal to 230. Since only S1 is closed, right? Switch 1 is closed. So the current only flows through heater A, but not heater B because switch 2 is open. So the current measured by ammeter is the current that flows through the heater A. So 230 divided 3.9, you will get 59 ohm. So my answer is 59 ohm. And the second part, calculate the energy transferred by the heater A in 5 minutes. When the energy is required, just use E equals VIT. V is 230, I is equal to 3.9, and the time, remember, because the energy must be measured in joules, time must be changed to second. So the answer is 2.69 times 10 to the power of 5 joules. 2.69 times 10 to the power of 5 joules. Or you can use the V square over R or I square RT. V square over R times T. Now the third one, S1 remains closed and S2 is closed. Determine the reading on the ammeter. S2 now is closed. When the S2 is closed, these two heaters are arranged in parallel. So you have to find the effective resistance of the two heaters. Effective resistance means total resistance. For parallel, remember, parallel circuit, the total resistance, 1 over R total, is 1 over resistance of A plus 1 over resistance of the heater B. So since these two heaters are identical heater, so you put 1 over 59 plus 1 over 59. So, okay, you get 2 over 59. But I want R, total R. So you just invert it. It is 59 divided by 2, and you get 29.5 ohm. Now, use the Ohm's law because we need the reading on the ammeter. Parallel circuit, they share the same EMF. So 230 I times 29.5. I is equal to 230 divided by 29.5, and you will get 7.8 ampere. So 7.8 ampere is the answer. Number 8, Fig 8.1 shows a diagram of part of a simple AC generator. How do I know this is AC generator? Do you see that the two rings, right, B, are not connected to any of the power supply, not connected to cell, not connected to battery? This is called AC generator because we want to generate electricity. Part 1, identify components A and B in Fig 8.1. A is called carbon brushes. Carbon brushes is to connect the slip rings to the external circuits. And B are called slip rings. There are 2 rings together. Each will be connected to each side of the coil of the wire. Right, okay. The second part, component C, is made of soft iron. Describe the effect of this component on the generator, because on the generator is to increase the output, okay, or the EMF output of the EMF. So because the EMF output, okay, I'll just say output EMF, output voltage. Done. Now, the coil of the generator rotates at constant speed of 2 complete revolutions per second. Sketch a graph of the EMF generated against time of the axis in Fig 8.2. The coil is in position shown in Fig 8.1 at time t equal to 0. So you can see that when t equal to 0, the coil of the wire, right, is in between the magnetic field of magnet. So, okay, maximum cutting of magnetic field occurs. So the EMF induced will be maximum. And then when the coil has already turned, okay, so if the coil is turning, so this part of the coil is facing the magnet, then no magnetic field will be cut, right? So they tell you that to complete, okay, so you draw a cost graph because you know that initially the EMF induced is maximum. So it is a cost graph, so I'm going to draw it. Okay, I try my best. Okay, this, and then okay, reach this maximum, and then going down, reaching this, and then going up. So you have to know the initial condition of the coil. If the coil is at that position, okay, the side of the coil is facing the magnetic field, then maximum cutting of the magnetic field occur, which induce maximum EMF. See, in power stations, transformers are used to step up voltage of electricity generated before it is transmitted through cables over long distances. First part, explain the advantages of transmitting electricity at high voltages. First of all, I would say that at high voltages, okay, I will explain everything first, but I'll do my explanation right here. First of all, you know power generated by the power station is constant. Okay, by power station, okay, I put P generated is equal to IV. Power, but you know power generated by the power station must be transmitted by wire cables before reaching our household, right? So there will be power loss, right, by cables, wire cables during this transmission. So the power loss, P loss, will be equals to I square R because all these cables are arranged in series. So I'm going to relate these two equations. I know that this is the same amount of current that is being transferred by the cables generated by the power station. So from here, I have I is equal to power generated over V. I sub into this equation. You see what happened? Power loss is equal to power generated square over V square times R. So power, remember what I told you just now? Power generated by the power station is constant, and the wire cables, because we normally use copper wire cables because copper itself is a good, okay, conductor. It has a good conductivity, less resistance. So the resistance of the copper wires would basically be the same, constant. Therefore, constant. Therefore, you can say that the power loss is inversely proportional to voltage squared. So when you step up to the higher voltage, you can actually minimize the power loss. So I would say that, okay, to reduce advantages of high voltages, reduce power loss during transmission. And then advantages, that means you need to give more than one, right? So when the power loss is being reduced, could you see power loss reduced? So the current is also reduced. Current reduced, okay, basically you can use, actually you can use thinner wire, right? Or thinner wire instead of using a very thick, right, cable wire. So you can use thinner wire during thinner cables so that the cost of the construction will be lesser, right? Thinner wire, okay, cables can be used and, okay, reduce construction costs. Now, the second part, a power station generates electricity at 25,000 volt. A transformer steps up the voltage to 300,000 volt. Primary coil of the step-up transformer has 450 turns. Calculate the number of turns Ns on the secondary coil of the transformer. So, number of turns, remember, Ns over Np is equal to Vs over Vp. NS is the one that I need to calculate. NP is 450. VS is 300,000. VP is only 25,000. And as just do your cross multiplication, and as you are supposed to get 5,400. There's no unit for number of turns. Now, number 9, strontium-90 is a radioactive isotope that contains 38 protons and 52 neutrons. Strontium-90 decays to form an isotope of yttrium by emitting beta particles. A part 1 suggests how the nucleus of a stable isotope of strontium differs from a nucleus of strontium-90. Explain your answer. Now, I want you to just remember this. A stable strontium nucleus has a stable configuration. So stable configuration of the protons and neutrons. So strontium-90 is less stable. Why? Because normally strontium-90, the radioactive, right, isotope normally contains more neutrons. Right, so it is unstable, so it will undergo beta decays to emit electrons. So it has to emit one electrons. So neutrons of the radioactive isotope will be converted to proton because it has excess neutrons. So I would say that suggestion is stable isotope of strontium has lesser number of neutrons as compared to strontium-90. So why? Because radioactive, okay, explanation is because radioactive isotope have more number of neutrons and readily to undergo decay process. That's it. Now, the second part, complete the nucleic equation for the decay of strontium-90 to yttrium. So I know beta is fast-moving electron, -1 is the proton number, right? The charge. So you balance nuclear number. So this is 0, this is 90. 90 plus 0 is equal to 90. So the proton number is 38 for strontium-90. So yttrium, it has to be 39 minus 1 equals to 38. Now, the third one, explain why scientists limit the amount of time they are exposed to radioactive strontium. First one, radioactive strontium. You hear the name radioactive. It is not safe, right? So radioactive strontium will emit beta particles. I would say that the beta particles are radioactive. They are harmful. So beta particle, why harmful? Because beta particles have high penetrating power. And ionizing power. They have high, but not the highest, but still high ionizing power. They could ionize, right? When they enter your body, they could ionize, okay, some of the neutral, right, water inside your body, right, to become ionized. This is dangerous. B. Yttrium is also unstable. A scientist places a sample of yttrium near a radioactive detector. Table 9.1 shows the count rate recorded by the detector as the sample decays. Now, Fig 9.1 shows a graph of count rate due to yttrium against time. Use Fig 9.1 to determine the half-life of yttrium. Show your working. Half-life of the yttrium, since the graph is being given, right? So you have to identify initial count rate due to yttrium only. So which is initial count rate is when time is equal to 0, you get this value. Okay, 48. See that? This is called initial count rate of the yttrium. So it is 48 counts per minute. At half-life is the time taken for the radioactive, right? The initial count rate of yttrium to decrease to half of its original value. So original count rate, 48 divided by 2, you get 24 counts per minute. So from the graph, where is our 24? 24 is right here. From 24, look at the time. The time is about, okay, this is a time. Okay, here. Somewhere here. Okay. Oh, wait, let me draw it nicely. I use the, okay, I use the ruler to draw it. So this is, okay, pen. So this is it. Oh, okay, this is it. Okay, what is the value right here? Okay, so you have to look at the value carefully, extra careful. So one box represents 4. Yes, 4. This is 76. So I got 76. So it is 76 hours. Okay, get this value here. That is the half-life. And the second part, explain the difference between the count rate in table 9.1 and the count rate due to the yttrium plotted on graph 9.1. You could see that the count rate when time equal to 0, table 9.1, the count rate is 68. There's only one reason. It is due to background radiation. Right, background radiation is a stray radiation. Our detectors are not selective. So the detectors would detect any count rate, any radioactive decay nearby. So table 9.1, 9.1, I'm so sorry, 9.1. Okay, table 9.1 contains background radiation detected, hence readings on all the count rates are higher than Fig 9.1. Or Fig 9.1 only contain the count rate of yttrium alone. Now, question number 10. Jupiter and the Earth are planets in our solar system. A, describe the composition of the Jupiter and the Earth. Jupiter is made of gas. Okay, made of gas. Because Jupiter is a giant planet. Whereas the Earth is a rocky planet. Now, B, the gravitational field strength at the surface of the Earth is approximately 9.8 Newton per kilogram. The gravitational field strength at the surface of the Jupiter is approximately 23 Newton per kilogram. Define gravitational field strength. It is defined as gravitational force gravitational force acting on a mass. Second part, state one factor which causes the difference between the gravitational field strength at the surface of the Jupiter and the gravitational field strength at the surface of the Earth. I would say that, okay, one factor, Jupiter is way, way larger as compared to the Earth. So I would say that one factor is the mass of planet that causes it to be different. C, state and explain the difference between the orbital speed of the Jupiter and the orbital speed of the Earth. So I want you to see this. Do you recall the equation of the orbital speed? V is equal to 2 pi r over t. Right, so I would say that explain the difference between orbital speed and the orbital speed of the Earth. So Jupiter, because it is far away from the sun, so it would take the longer time to orbit the sun. So longer time, orbital speed of the Jupiter will be lesser. So I'll say orbital speed of a Jupiter is lesser than orbital speed of Earth. Explanation, why do I say so? It is because not orbital, I'm so sorry, Jupiter. Okay, Jupiter is further away from the sun. It takes longer time to orbit the sun or the distance. Okay, so that is why, okay, as compared to Earth, to Earth. So that is all about the discussion today. I hope you gain some benefits. If you like this video, please give this video a like and please subscribe to my YouTube channel for more exciting past year question discussion and some concepts. Thank you very much. See you again in my next video. Bye.